Okay, so now that we've got our movement down and our player can move around the world, we need to give them the ability to jump around in the world. So we'll go back into our script again. Like I was saying before, we want to change our public rigid body back to being private because we don't need to be able to make changes to that. And then down here, we're going to look at making our player jump. So actually, if we just go back to our input in our project settings down here, we just collapse that one. But we can see here we have an entry for jumping. So our jumping has, we can use the space button, or on a controller it will also use, say on the Xbox controller, it'll use the A button to jump, which is handy because again, it's stuff added in so that we don't need to be worrying too much about it. So if we go back into our script, so now we know that we want to use the jump ability. So we'll go type in an if statement again. So we want to check if our jump button is being pressed. So we'll say input dot, and this time instead of using axis, because it's not a directional input that we're using we're going to be checking if a button is being pressed basically. So we'll say if input dot get button, and we'll see here we've got 3 different options here for get button in the autocomplete. So get button will basically be true as long as the button is being held down. So if the button is still being held down, then this will be true. So basically, if we're jumping, if we were to use get button, it will only happen when our get button is being held down, and so our player would keep jumping forever and ever and ever, and that would be no good to us at all. We've also got get button up, and that occurs obviously when the button is being let go. So when our button is held down and then let go, our player would jump at the moment when our player lets go of the button, which is something that people have used in games in the past, but it's not it's not the way we want to do it. Say for example, if you wanted to be able to hold a charge to be able to jump up, you'd hold the button down and charge up a jump, and then on the let go was when the jump would actually occur. But what we want to use is get button down, and get button down occurs only at the very first moment the button is pressed. So obviously if our player is going to be jumping, that's the moment we want our player to be able to jump. So we will say get button down, and then we put an open bracket like this, and we know we want to use the jump button from our input over here. So we got jump. So again, we need to put inside a quotation mark like this, jump, and another quotation mark, and then close that bracket like that. Okay, and then we actually need one more close bracket, I just realized. So we can see actually we closed this bracket that was related to the first one, and because we're like right beside this one, it actually tells us that one is related to there. But we also have another open bracket here, so we need to make sure and close that one as well, like that. And this time we're not actually checking if it's greater than 0 or anything like that. All we need to know is if the get button down of jump is now true. So if it's true that the player has just pressed the jump button, we want to do something. And the something we're going to want to do is add some jump ability. But we need to know how much jumping we're going to add. So back up here again in our where we've got our move speed and our rigid body, but before the start function, we're going to add a new variable that we're going to say public float again, because it's going to be a number value, obviously, a number that we want the player to be able to jump up into the air. And we're going to say public float, we'll call this jump speed, like that. So now we have a number that we're going to be able to apply to our rigid body again to be able to fire our player up into the air. So here we're going to say my rigid body again, and that velocity again, it's going to be equal to a new vector 3, and then open the bracket. So this time, because we know we're going to be jumping, we want to make changes on the y-axis, which is our up and down, but we want our x-axis to remain the exact same. So much like last time we did rigid body.velocity.y to make sure our y-axis stayed the same, here we're going to say my rigid body.velocity.x, like that, so that we make sure that the x-axis stays the exact same, and then the y-axis we want to give it the jump value that we're adding. So we'll put in our jump, if I could type jump speed like that, And then again, our z-axis, we don't need that to change. We need that to be 0 always. So we're going to leave that as 0. And then we'll hit save. And that's our jump added to the player. So we're going to go back into the game here. And now we're going to test how our jump actually looks as we're playing the game. So we'll let that compile in the bottom corner there. And then we'll scroll down here to our jump speed, our player controller script, and we're going to make a change to our jump speed, and we're going to give this a value of 10, for example. Actually, no, we'll give it a 5, just an example to show how it jumps. So if we go into our game here, if we jump the player, we can see he kind of jumps a little bit, and he kind of floats back to the ground like that. So we need a little bit more jump than that. We'll make his jump speed 10, say. He jumps. Now that's a little bit high, but also we notice that he's not really falling very fast in our game. He could really do with falling a good bit faster than that. We can still move side to side and we can jump now around a place like this, but he's falling very, very slow. So we're going to increase our gravity scale to about 2.5, which is just what I've kind of worked out with. I think looks good myself. So we can jump and we can see he kind of falls with a bit more solid speed down to the ground. But of course you can change the gravity scale to be whatever you would prefer to suit your character, but we can also make some changes to the jump speed. So at the moment he's not really able to jump too high, but he's able to jump just high enough to be able to reach a few platforms, and we've fallen down to the ground like that. So what we need to make sure we do then is, once we stop the game, our gravity scale, as discussed before, will go back to 1, so we need to remember to set that back to be 2.5, and our jump speed went back to being 5, so we need to set this back up to being 10. We might actually set it to be 12, might look a little bit better. And basically it's about finding a good balance of those two things for yourself, so that we know that, however you think the jump looks good on your player. I think this looks good, so we're going to leave it at 12 and 2.5 for those two values. And basically that's our jumping covered. So we've kind of got the basics of that line down, but the problem with our jumping so far is it's all good, we can jump, but if we actually just keep pressing space, we can just keep jumping forever and ever. So that's not going to be exactly how you would want your game being played, because we can just bounce along like this and we'll probably end up never dying. So that won't be a challenge for the player. So we need to make sure that our player knows when he's on the ground, so that we can make sure that we can only jump when we're on the ground. So that's what we're going to cover next. Okay, so now that our player has the ability to jump up in the air, we want to make sure that he can't just keep jumping forever and ever. We want to make sure that our player can only jump when he's on the ground down here. And the way we're going to do that is by adding just a kind of a point at the player's feet to just check and see if the player is on the ground, basically. And the way we're going to do that is we have to know what is the actual ground going to be. And one of the built-in things within Unity is we can assign different objects to be parts of different what are called layers. So we've got all our ground and our platform things here. So what we're going to do is give them a layer that will be called ground. So if we go over to our layer thing in our layer drop down in our inspector here, we can see there's a few kind of default things already added in, but they're not what we want. So we want to go to add a new layer here. And just in the first box, the first empty box, the first few built-in ones like this are kind of not available to be messed around with. So the first empty slot here, we'll just type in ground like that. And then we're going to go back to our platform here. And what we want to do, actually no, we should make these changes to the prefabs that we've already set up before. So in our prefabs in here, what we're going to do now is on each one, we're just going to go to the layer and make sure it's set to ground. We can make it change the children, that's fine. We can actually so we've set that one there, we can actually select here all the rest of them and just go to layer, ground, we'll change the children and we'll see that they're all set to ground. So now we know that all of these objects are set to be the ground, so that if we have a point that we're using to check if something is the ground below us, we know that we're interacting with something on the ground. And while we're here, we might as well set the player's layer to also be a player. Just so in the future we might want to be able to use the layer stuff to affect changes on our player itself. So we want to make sure that we have that as a separate entity. So we'll go to here and we'll set player. So that's perfect. So now we need to actually check how we're finding the ground. And the way we're going to need to do that is by making some additions to our script. So we'll go into our scripts folder and we'll open up our player controller. And once that's open in Unity, or in MonoDevelop, sorry, we can see what stuff we're going to need to add. So, like I said, we're obviously going to need a certain point in space that we're going to want to use to check where the ground is. So, if we just add a couple of lines down here, what we're going to do is say public transform, and we're going to call it ground check. So what a transform is basically just any object in the world that has a position. So if we go back into our Unity and we look on our player or any other object, as I've discussed in an earlier episode, the transform here is on every single object. Any object we put into the world automatically has a transform, so that it can have a position in the world, a rotation, and a scale. So basically what we're saying is we're going to have a point in space that we're going to use as the center of where we're checking where the ground is. So we go back to our script here. We want to make sure we put our semicolon at the end. So if we have a point like that, actually this should be a capital T. That's why we got it turned red there, because there was an error in it. So if we're going to use a point in space to check where the ground is, we needed to know how far outside of this point can I go to check whether there's ground below me, because we don't want it to see if there's ground 20 meters below. So what we're going to do is basically draw a little circle around this point, and we're just going to check if there's some ground within that circle. Basically we know that we're on the ground. So we need to know how big that circle will be, so we need to set a certain amount of radius. So for that we're going to say public float ground check radius, and that'll be the size that we're going to use. And the third thing that we're going to need to check this stuff is, because we just set up that all the ground pieces and the platforms will have a layer of ground set, we need to be able to check what layer is set for any object that we're touching, because if we're jumping onto the head of, say, an enemy or anything like that, obviously that won't have set to ground, and we don't want the player to be able to just jump off the top of an enemy or something like that. So we want to say, and not necessarily an enemy, even like a spike trap or any other kind of trap that we set up in the game. So we want to say public, and this time we'll say layer mask, and I'll show you what layer mask is now in a second, and we'll just call this what is ground. Okay, so I'm going to save this and we're going to pop back into Unity here. So we've added 3 little things to our script. Once it compiles in the corner down there, once it finishes spinning basically, we'll scroll down to here, and now we've got a ground check, which is going to be a point in space. We've got a ground check radius, and we've got what is ground, which is our layer mask. And the layer mask is basically just checking what layer is it that we're going to use, and it creates this little drop down, and we have all the layers that we've created. So we can see if we scroll up here, they're the same as the ones we have available here. So we'll scroll back down, and we know we want to check for anything that's in the layer ground, so we want to leave that there. But just as an example, say in the future we wanted to check, we did want the ability to jump off an enemy's head, for example, we could just add another thing just by clicking on it like that, and what it does is it says that both of those things will be considered ground. So you can have multiple things clicked like that, and you can unclick them as you want to, and you end up with whatever combination of those things you want to actually use. So we're going to need to create this point in space that we're going to use on our player. So I'm just going to switch back to the scene view here. I'm going to zoom in on the player by scrolling our wheel up, and what we're going to do is right click on the player here, and we're going to create an empty object, and what that'll do is it'll create the object as a child of the player here. So it's by default it's attached to the player. We're going to go to our movement stuff here, and we're going to drag this so it's just straight down, and we want to line it up basically with the bottom of the player's feet. It doesn't need to be 100% exact, because like I said, we're going to have a little circle drawn around this point that is going to represent where we're checking what ground we have. So now that we've added that, we're going to rename it here, and we're going to call it ground check. And then on our player, we'll scroll back down to our slot on our script here, and we're going to drag that into place in there. So now we know we're talking about that ground check. And we'll need to set a ground check radius value here, and you can mess around with this and see what suits for yourself, but the value that I'm going to be using here is 0.25. So that should just create just a circle kind of around this whole bottom area at the bottom of this collider here. Because if we look, our box collider's width is 0.5, so if we set our radius to be 0.25, that'll be the whole exact width of this box that our player is standing in. Okay, so we go back into our script here. So now we have the things that will let us check whether we're grounded, but we need something that our script can know at any particular time whether we're grounded or not, because we don't want to be checking every single time that we do something. We don't want to be checking the same thing over and over again. Say if we wanted to do jump here, this checks if we're on the ground, but we want to be able to do something else that relies checking if we're on the ground. We don't want to have to check every single time. What we want to do is check once and then put that into a value. And so what we're going to use for that is a thing called a bool. So we'll say public bool, and we'll call this is grounded. And what a bool is basically just a true or false statement. So if I save this here, we go back into Unity, what it shows up as on our player script, once it compiles again, we'll see down here, we'll see that it just appears basically as a checkbox. So it can either be true or false, and that's it. So now what we're going to do is check at which point our grounded should be true. So we'll just say is grounded here, which is our bool, and we want that to be either true or false. So how do we decide whether that is true? Well, we're going to use a thing called an overlap circle, which is basically going to draw a circle not physically on the screen that we can see, but just in the imaginary world of the computer. It's going to draw this circle around, and it'll tell us whether we're grounded or not. So we just type in here physics 2D with a capital D, and then physics 2D dot overlap circle. Okay, and then an opening bracket here. So if we look at the little kind of tooltip helper that opens up here, our overlap circle, we can see we have one of 4 here. So there's a few different options of things we can do with this. So by default, it can look, we'll need a point in space and we need a radius. But if we press down to the version we're going to use, we need a point in space, a radius, and we need a layer mask. So that's why we use the layer mask up here to determine what is the ground that we're looking for. Because, for example, the very first one here would use a point in space and a radius, and it would just check if there's anything within that circle that it creates. Whereas if we're looking for a specific layer mask, it will just check for anything only in that layer. So if we're looking for at first, we're looking for a point in space. So we know that the point we want to use is our ground check transform. So we will say our ground check like that. But as we discussed, our ground check or any transform in general has a position, a rotation, and a scale. But we don't want rotation or scale, so we specifically want position. So it's ground check dot position. Next we need a radius, and we've set up our radius, so that's our ground check radius. And then finally we have our layer mask, which is our what is ground up here. So what is ground? So now we have all the necessary components to do this little check. So basically what this little thing does is it creates the overlap circle around the point that we have to the given size and checks if it's the right layer within it. And if all of that is correct, then it will set is grounded here to be true. And if all of it is wrong, then it'll set is grounded to be false. So now we know at the start of every update loop of the game, it's checking to make sure whether the player is on the ground or in the air. And so now that we know whether the player's on the ground or not, we can add an extra little thing to our input get button down here. And basically we're just saying if our input is currently the jump button being pressed, and we want to add 2 ampersands like that, and what that means is and. It's the way of writing and basically within C#. So what we're saying is if our input jump button is being pressed and is grounded here, which is the value we've set, if is grounded. So what we could say here is grounded is equal to true. Oop, if I spelled that right. If is grounded is equal to true, but we can get rid of that bit because our is grounded is only a bool value, or a boolean value as it's called. So it can only be either true or false. So we know that we can just check whether that thing is true or false. So if it is true and we're getting a jump press down, then we can do our jumping action down here. Whereas if it's false and we press a jump button, then it won't run this thing. So that's why we say and here, because if it means that both of those things have to be true to run through this stuff. We could, for example, this isn't what we want to do at all. If we put 2 little vertical bars like that, that means or. So it would make the player jump if we were pressing the jump button or if we were just on the ground. So that wouldn't be very good. We just have our player bouncing around the whole place all over repeatedly, and it just wouldn't be good. So we'll put our ampersands back in and we'll save this now, and we'll go back in here, wait for it to compile once more, and we should be able to play the game, and we should be able to jump up into the air just the way we want to. So we hit play, and now there we go. We can jump just the way we wanted to, but we can't. Oh, I fell down the side there. We can't jump away up into the sky. We can only jump, no matter how many times I press this button, we're only jumping once. And that's just what we want to happen. So now we know that our player can stay on the ground. But he still kind of looks like he's not very excited with what he's doing. So we need to add some animation. Okay, the next thing we want to do is add some animation to our player so it looks a bit more interesting than him just sliding around in the world, which is obviously not very entertaining for our players. So what we want to do is go to Window up here, and we want to scroll down until we find the animation window. So we're going to open that up. And it opens up in the middle of the screen like this, so we don't want it kind of hanging out in the middle of the screen. We want to drag it down so that it falls in line with these other tabs down here and pop it down there. So the way animation works within Unity, or at least the way we're going to be using it, because we're using a sprite like this, which is just one solid image, because we're using just a sprite like this, we want to be able to use sprite-based animations. So we're just replacing the image with another image to represent the character running. Whereas if you were using, say, multiple pieces for body, you'd be moving their arm up gradually as they run along and stuff like that, and moving their legs into different positions, which can equally be done with the animation toolset built into Unity. But we're going to just focus on doing sprite-based animations. And because we're doing that, we need to be able to drag animations into our timeline, which we'll see in here in our animation window in just a minute. But we're going to want to drag them into there from our project window. And at the moment, if we have our sprites all lined up like this, it's going to be awkward to drag our sprites from here, drag it over to the animation window here, and then wait for that to open and then put it into place. So what we're just going to do for the moment is grab our project tab here and move it up to the right up here. So it goes just beside the inspector here like this. There we go. So we want it so it makes a little line up here so that when we let go of it, it'll create 2 separate little bars here, because we want to keep our inspector open in case we want to make any specific changes with that. Okay, so now we'll switch back to our animation window here. And what we're going to do here is, it says no animatable object selected, that's fine. But we're going to highlight our player like this. And now it gives us an option to begin animating the player. So we're going to, and it says to begin animating the player, create an animator and an animation clip. So we're going to do that by hitting create here. And what we're going to do is, first of all, we go up into our assets folder, and then we're going to create a new folder that we're going to call animations, and we're going to go into there, and this is where we're going to store all our animations for various different things. But we're just going to call this animation player, we'll just call this one player walk, and save that. And so now we get a little timeline appears, and what this also does is if we go into our animations folder, so that's our player walk animation that we just created. Obviously there's nothing in it just yet, but it also creates an animation controller, which is something that controls all our animations, and we'll take a look at that just here shortly. But it also, on the player, if we scroll down, it creates an animator object on the player by default. So this is what's going to control how our player animates and stuff like that. It's just important to note that it's automatically applied to our player. So back into our player walk here, if we go back into our art folder, and we'll scroll down to where we have our little walking dude. If we scroll down, and the two sprites that we're going to use here are 28 and 29. So basically all we have to do here is grab 28 first, and we'll just drag it in so it drops into the timeline like that. And then we'll grab 29 and we'll drag it so that this little diamond that appears on this line here, we don't want it to overlap the other one. We want it to appear just one space over from the other one, like that. So now if we scroll in a little bit just to look at our player, and if we hit the play button, what we actually see is it's going so fast it kind of looks like he's staying still here. Oh no, hold on, I just realized that my second sprite that I dropped down didn't actually change. Hold on. So let me just drop in 28 again here. No, it's doing the same thing. I may have put it in a little bit too close. Okay, yeah, there we go. You need to put a one extra little one away. Sometimes Unity animator is a little bit weird like that. So we just needed to put it a little bit further away. So we've now actually got the same animation appearing twice there. So let's just drop the first one back in. So there we go. If we move the timeline ourselves, we can see our legs moving back and forward. If we hit play, we'll see it's going way too fast. So this is what I thought was happening a second ago, but I was confusing myself. But it is going so fast that it's not reliable at all. And the way we can make it look a little bit more slow and a little bit more like he's actually moving is if we just stop this here. If we go to samples, and we're going to change this to be about 8, we'll see that the whole bar gets much wider. Because what's happening here is we see we've got 0, 0, 0, 1, then nothing there, but it is saying 0, 2, 0, 3, 0, 4, 0, 5, etc. Because these are all like frames in between each section, or in between each second. So we've got a full second here, and in between we've got 8 frames of animation. So that's what our sample rate is now down to 8 frames per second, basically. That's what our samples number means here. So if we hit play on this little thing down here again, we'll see, okay, now his legs are actually moving at something a little bit more of a sensible speed. If we were to slow it down even more again, now it looks like his legs are open and closing, which will make a little bit more sense when he's actually moving around in the world. But for now, that's okay, and we're happy with that. So that's our very basic, simple little player walk animation. If you're using something with more sprites, for example, and you have, say, an 8-frame animation walk cycle, all it means is you're just adding in some more sprites along the way, and you'll be adjusting their sample rate. But it works equally whether you have 2 frames or 100 frames or 1,000,000 frames, whatever. You probably don't want 1,000,000 frames though, because that's a lot of memory you're using up. But we want to have more animations than just our walking animation. So we're going to hit this little drop down where the player walk is, and we're going to hit create new clip. And we want to make sure we're still in our animations folder, which we are. And we're going to call this one player jump. So this will be our jump animation, which is going to be even more straightforward than our walk animation was. All we're going to do is find the jumping sprite, which if we scroll up through these guys here, we should find it. There we go. It's sprite 21. We just drop that into there, and because we're jumping, we don't need different animations for when he's jumping. We only need this one frame. So rather than having to worry about adding more frames or anything like that, or changing the sample rate, it won't make any difference, because if we hit play here, all we're getting is the player like that. So that's all we need for our player jump, and we need one more animation, which we'll call player idle. And our player idle animation is just going to be our player kind of standing still, but rather than standing still and facing the camera like we have for our default sprite at the moment, we're going to use the next sprite down, which is kind of standing a little bit to the side, so he looks like he's ready for action and he's just waiting for our player to continue moving. So we'll move that into there, and we'll turn off this little record button like that, so that our player returns to normal and we're not making any changes. And just as an important lesson to learn, actually, if we were to leave our record button active like this, and then we were to say grab our player and move him, what's happened is that movement has now been recorded in the animation, and not even the movement, is the specifically that our player should be at this point in space at this time in the timeline. So just as an example, if we were to go to here and move him again in our animation here, if we were to hit play, he'll repeatedly do all this stuff, which is obviously not what we want happening at all. So you want to make sure that when you finish making any changes to animations, you always turn off this little red button here. And a handy indicator is that these buttons up here will turn red whenever this animator is active. So if I deactivate that now, we'll see they go back to being black. So I'm just going to undo both of those changes. So now our player sprite is just back to only affecting this thing here. So now we've got 3 basic little animations for our player to use, and the next thing we need to do is combine them all together and work out how can our player himself actually use these, and so it looks like they're actually doing something in the world. Because as it stands, obviously, at the moment, we've created those animations, but because the very first animation we created, hold on, where's our player gone? Oh, he's outside the camera, that's why. The very first animation we created and was then set by default is the walk animation. So at the moment he looks like he's permanently walking into space. He'll look like he's walking properly when we move, but if he jumps he'll do the same, and if he stands still he's doing the same. So that's no good to us. So we need to actually set up our animation controller so that we're making him look like he's moving properly. So that's what we're going to do next.